This is the planet Mercury, the fastest, the smallest, and the closest planet to our Sun. A scorched wasteland hot enough to melt lead on one side, cold enough to freeze water on the other. In the next few minutes, we're exploring Mercury's incredible world and the surprising science that makes it unlike any other planet. At first glance, it might seem like a dull, grey, crater-covered world with very little going on, but beneath its rocky surface lies a planet full of surprises. From extreme temperatures and frozen water ice to an enormous metallic core and a magnetic field that scientists are still trying to understand, Mercury is one of the most fascinating planets we've ever explored. Although Mercury may seem like a modern discovery, humans have actually known about it for thousands of years. It is one of only 5 planets visible to the naked eye, meaning ancient civilizations could observe it without telescopes. The Babylonians recorded Mercury's movements as early as 3,000 years ago, while the ancient Greeks and Romans carefully tracked it across the sky. The Romans eventually named it Mercury, after their swift messenger god, because the planet appears to move quickly through the heavens. Mercury orbits the Sun at an average distance of about 58 million kilometers, or 36 million miles. That's less than half the distance between Earth and the Sun. Because it's so close to our star, Mercury completes one orbit in just 88 Earth days, making it the fastest planet in the solar system. But Mercury's rotation is much slower than its orbit. It takes approximately 59 Earth days to spin once on its axis. This creates a unique relationship known as a 3-to-2 spin-orbit resonance. For every 2 trips Mercury makes around the Sun, it rotates exactly 3 times. As a result, one complete solar day, from one sunrise to the next, lasts about 176 Earth days, which is twice as long as its entire year. Mercury is incredibly small. It measures just under 4,900 kilometers, or about 3,030 miles across. That's only slightly larger than Earth's moon. Despite its size, Mercury is surprisingly dense. In fact, it's the second densest planet in the solar system after Earth. One reason for this remarkable density is its enormous iron core. Scientists estimate that nearly 85% of Mercury's radius is made up of this giant metallic core. Compared to Earth, Mercury's rocky outer layer is extremely thin. Some scientists believe a massive collision early in the planet's history stripped away much of its outer crust, leaving behind the oversized core we see today. Mercury's surface closely resembles our moon. It's covered with countless impact craters formed by asteroids and comets over billions of years. Since Mercury has almost no atmosphere to protect it, incoming space rocks strike the surface directly, leaving permanent scars. One of Mercury's most famous features is the Caloris Basin, one of the largest impact craters in the solar system. Stretching approximately 1,550 kilometers across, this enormous basin was created when a gigantic asteroid slammed into Mercury billions of years ago. The impact was so powerful that it generated shockwaves that traveled through the entire planet, producing unusual hills and fractured terrain on the opposite side. Mercury also has enormous cliffs called Labat Scarps. Some of these cliffs extend for hundreds of kilometers and rise more than a kilometer high. Scientists believe these formed because Mercury slowly cooled over billions of years. As its massive iron core contracted, the planet shrank, causing its crust to wrinkle much like the skin of a drying apple. Despite being closest to the Sun, Mercury isn't actually the hottest planet. That title belongs to Venus because its thick atmosphere traps heat through an extreme greenhouse effect. Mercury has almost no atmosphere, only a very thin exosphere made of atoms blasted off its surface by solar wind and micrometeorite impacts. Without an atmosphere to hold heat, temperatures change dramatically. During the day, surface temperatures can reach around 430 degrees Celsius, or 800 degrees Fahrenheit. At night, they can plunge to minus 180 degrees Celsius, or minus 290 degrees Fahrenheit. That's a temperature swing of over 600 degrees Celsius, making Mercury one of the most extreme environments in the solar system. One of Mercury's biggest surprises was the discovery of water ice. At first, that seems impossible. How could ice exist on the closest planet to the Sun? The answer lies at Mercury's poles. Some craters near the North and South poles never receive direct sunlight because the Sun always remains low on the horizon. These permanently shadowed regions stay incredibly cold, allowing water ice delivered by comets and asteroids to survive for billions of years. Radar observations from Earth first hinted at these icy deposits, and later spacecraft confirmed their existence. Another mystery is Mercury's magnetic field. Most scientists expected a small planet like Mercury to have a cold, inactive interior. Instead, Mercury possesses a global magnetic field, although it's only about 1% as strong as Earth's. Researchers believe this magnetic field is generated by partially molten liquid ions still moving inside Mercury's enormous core. Even more surprising, the magnetic field isn't perfectly centered. It's shifted toward the planet's northern hemisphere, something unlike any other planet in our solar system. Mercury also has no moons and no rings. Being so close to the Sun makes it difficult for the planet to capture or hold on to natural satellites. Because Mercury stays close to the Sun in our sky, observing it from Earth can be challenging. It's usually visible only shortly before sunrise or just after sunset, when sunlight doesn't completely overwhelm it. For centuries, astronomers could only study Mercury through telescopes. Everything changed when spacecraft finally began visiting this mysterious world. The first mission to Mercury was NASA's Mariner 10, launched in 1973. Reaching Mercury wasn't easy because spacecraft traveling toward the Sun must slow down significantly rather than speed up. Mariner 10 became the first spacecraft to use a gravity assist maneuver, flying past Venus to redirect itself toward Mercury while conserving fuel. Between 1974 and 1975, Mariner 10 flew past Mercury 3 times. It captured thousands of images and mapped about 45% of the planet's surface. The mission also discovered Mercury's magnetic field, completely surprising scientists. However, because each flyby occurred under similar lighting conditions, more than half of the planet remained unexplored. For decades afterward, Mercury remained largely a mystery. NASA returned with a far more advanced spacecraft called Messenger, launched in 2004. Getting into orbit around Mercury required an incredible journey lasting nearly 7 years. The spacecraft completed flybys of Earth, Venus and Mercury itself several times before finally entering Mercury's orbit in 2011. Messenger completely transformed our understanding of the planet. It became the first spacecraft to orbit Mercury and eventually mapped almost the entire surface in remarkable detail. The mission discovered evidence of ancient volcanic activity, proving Mercury had once been geologically active. It confirmed the presence of water ice inside permanently shadowed polar craters. Scientists also detected surprising amounts of sulfur, potassium, and other volatile elements that many researchers believed couldn't survive so close to the Sun. Messenger carefully measured Mercury's gravity and magnetic field, providing new evidence that much of its iron core remains molten today. After more than 4 years in orbit, the spacecraft eventually ran out of fuel. In April 2015, Messenger deliberately crashed into Mercury's surface, ending one of NASA's most successful planetary missions. Today, scientists continue studying Mercury through an international mission called BepiColombo. Launched in 2018, BepiColombo is a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, with contributions from NASA. Instead of carrying one orbiter, BepiColombo carries 2. The Mercury Planetary Orbiter is designed to study Mercury's surface, geology, and internal structure, while the Mercury Magnetospheric Orbiter focuses on the planet's magnetic field and its interaction with the solar wind. Because Mercury lies so deep within the Sun's gravity well, reaching it requires multiple gravity assists. During its long journey, BepiColombo has already completed several flybys of Mercury, capturing spectacular new images and testing its scientific instruments. The spacecraft is expected to enter Mercury's orbit in 2026, where it will begin its primary science mission. Scientists hope it will answer major questions about Mercury's unusual magnetic field, oversized core, geological history, and the formation of rocky planets throughout the solar system. Even after decades of exploration, Mercury continues to challenge our understanding of planetary science. Its giant iron core, shrinking crust, ancient volcanoes, magnetic field, and hidden ice deposits make it far more complex than anyone once imagined. Every mission has revealed new mysteries instead of simply providing answers. Although Mercury is the smallest planet, it has played an enormous role in helping scientists understand how rocky planets form and evolve. It reminds us that appearances can be deceiving. What looks like a lifeless grey rock is actually a dynamic world with a rich history stretching back more than 4.5 billion years. As new discoveries continue to arrive from BepiColombo, Mercury may once again surprise us, proving that even the planet closest to the Sun still has many secrets waiting to be uncovered.